Good evening, everybody. I am Kris Mortensen, and going to kick off tonight's talks with certificate services or Windows PKI, and yeah, just introduction of who I am. Again, name's Kris Mortensen. I do security work, or pretend to, and we'll all see how well that goes. Otherwise, I have a background mostly in systems engineering, Microsoft world kind of things. If you ask me about Linux stuff, I'll probably lie and then defer you to Brad. And so I think that'll work out pretty good, right? So otherwise, tonight's presentation is really just kind of me looking at certificate services from a Windows world. I titled this A Look at Best and Not So Best Practices. My goal was to give everybody kind of an introduction in some things that are terrible and some things that are pretty decent, and hopefully some things that you can do, like if you have a certificate authority and you wanted to go back to work and do something better with it. So with that, we'll kick off. I wanted to start, my slides aren't going to advance. That's awesome. Okay, first things first, I feel it's important to tell you guys why you care. I know that a lot of people probably have not administered a certificate authority. They probably, if you have one, it's probably sitting there doing its own thing, and you don't necessarily know what it's doing, and it might not be that big of a deal. And that's okay. So some quick reasons why you might care is your PKI, your certificate authority, whatever we're going to refer to it tonight as, is part of your confidentiality and integrity tool set. It's another one of those things that it's as strong as your weakest component. So if your CA, certificate authority, I'm watching the acronyms tonight, if that's poorly configured or if it's doing things that it ought not be doing, then it's weak, and you might actually be in a poorer position than when you first had it deployed. We have lots of consumers of a PKI, browsers, servers, applications that are homegrown, applications that are bought, lots of things. Remote access is another thing that kicks in here. So a lot of us are probably using VPN as a remote access tool, and for our second form of authentication, we're probably using a certificate. If your certificate services aren't done well, this is going to be a problem, and we'll talk through that as we go through the night. And then my last point there, in that rebuilding is terrible. So I've noticed kind of a trend as I've worked with various people on certificate services, and the trend is when we build it, we're going to set everything up so that we don't have to do anything for the next 20 years, which means by that time I'll be at another job or I'll be dead, and I won't really care what your certificate authority is doing, and I can just set it and forget it. The problem with that is that when something breaks, you have no idea what's broken about it. You have no idea how to fix it. You can't tell anybody how it's working. And that means you're either just going to rip it out and rebuild, or you're going to pay somebody a lot of money to come in and tell you how it's doing. Now, to be fair, if the person that you want to pay a lot of money to is me, I'm good with that. Build it for 20 years and hire me, and I'm okay with that. Here we go. So narrowing the scope, some specific things that we're talking about. We are only talking about Microsoft certification authorities. I don't really know much about the Linux side of the house and certificate authorities that could exist there. We're talking about general rules for designing, maintaining, and consuming. I don't want to get into great specifics because we could be here forever. So we're not talking about the random certificate authorities. We're not talking about exhaustive design rules. Just kind of going into some random thoughts. Here we go. Design considerations. Doing stuff to avoid throat punch Thursday, as I like to call it. So these are things that if you do these, I might work hard to find you. And I know that sounds stupid because I'm not really that ominous of a person, but wicked throat punch. So don't build your CA on a domain controller. How many of you guys have seen a domain controller that's a certificate authority? It's really, really bad, and I'll just go really briefly into why it's bad. First, your certificate authority is largely name-based. To be fair, new Microsoft technologies have it set up so that you can change the name. Old CAs, you could not do that without ripping it down, and how many people want to actually rip down a domain controller at the same time? Nobody does, right? Secondly, if you have your domain controller, you've got Active Directory users that are on there, and you've got hashes and all kinds of really cool things. That's one component of the identity. On the flip side, you've got some keys sitting there, the keys for your certificate authority that can issue other identities. You've basically paired both identities onto the same server so that you can use those two identities as multiple factors in some other endpoint. So you basically just buried all your cash in the same can. Really, really bad choice. Don't build your offline root as a virtual machine. If it's a virtual machine, it's not really offline. I can easily add a virtual NIC at any time. I can add a virtual hard drive at any time and pass private keys back and forth. Floppy disks, if you really want to get crazy. You can do a lot of stuff. You can do some, if you're ESXi, some Power CLI to dig into the guest VM and start transferring stuff back and forth. Don't do that. It's a really bad idea. Snapshots are super fun, too, when it comes to VMs. So, yeah, just a bad idea. Don't build a single-tier architecture. Single-tier architecture says that my root certificate authority is also going to be my issuing certificate authority, and I'm just going to start issuing things, and I'm not going to have any protection for that root. Again, really, really bad idea. Don't have admins everywhere. This is kind of a general best practice, and I would hope that as a security group, we would acknowledge this and just not do it anyway. But the catch for Windows is that by default, all of your private keys that get created so that you can issue a certificate are only protected via NTFS permissions. If I'm an admin on my box, then my private key is protected by those permissions. And if you catch my box and become me, you don't even have to escalate your privileges to steal my private key or to issue another certificate or whatever you want to do. You just became me and can roam throughout my system as me, totally under the radar. Don't use default certificate templates. I'm not sure of my audience. I don't know how many of you are like Windows people, but when you spin up a Windows certificate authority, by default, it creates a ton of certificate templates and says, here, use me. These are sort of like, you know, easy bake oven kind of templates. The catch is they're, for the most part, really bad. For example, a user template, which we would all probably use, user certificates, by default requests email addresses to be as part of the request process, and also includes EFS as one of its functions, as one of its subjects and purposes that are available for the certificate. So we'll talk about the email thing a little bit later when we talk about SMTP Exit modules. But as far as EFS, first, EFS, encrypted file system, is a terrible, terrible technology. It's just really bad. But further, how many of us are willing to go ahead and put a certificate out there, have somebody accidentally encrypt a file, and then, or purposefully for that matter, and then us as admins realize, wait, we never set up any sort of key archival process or any sort of recovery process, key recovery agents, and now that end user just encrypted stuff and we can never get it back. It's basically a homegrown ransomware system that we just made, which is cool if you're into that sort of thing. And then lastly, don't deploy the web enrollment site. If any of you guys have ever seen the original certificate services deployment, there was this really terrible website that got deployed so that you could go and you could say, I'm a user, I need a certificate, and all this good stuff. And essentially what this comes down to is the early 2000s called and they want their website back. It hasn't been changed literally since 2003. It has no function at this point. If you're updated in your certificate authority, you're using version 3 templates, and the website doesn't even work. And yet people are still deploying it. It's still available. It doesn't make any sense. Just leave it alone. At the end of the day, there's also other technologies that have replaced it, like certificate enrollment services, where you can do enrollment over HTTPS as opposed to RPC for your automated systems. So yeah, we'll keep going. Some things that we can do for design considerations. First, do ask why. Yes. Further? Is that better? Okay. Sorry about that if you guys couldn't hear me. As you're building a certificate authority or considering building a certificate authority, do ask why. Why am I building this? At the end of the day, if you're only building it because you need a second factor for your VPN endpoint, there's probably better solutions without the overhead of having to administer a certificate authority. If you have some other use cases, fine. Have that conversation, think through it, build it for the future. Don't do just some one little tiny use case. Second one, everybody knows the KISS acronym, keep it simple, stupid, right? And what I'm talking about here is Everybody that I talk to that wants to deploy a CA says, we've got to make our certificate authority highly available. It's got to be in a cluster. It's got to be running all the time. It's got to be awesome. And then I get to ask them, why? Why do you have to be able to issue certificates 24/7? Are you a public enrollment kind of company? Are you issuing certificates all the time? No, these are private certificate authorities. And so at the end of the day, if there's a disaster, nobody really cares if you're issuing certificates. They care that the certificates that you've issued are still usable. So don't add clustering into your certificate authority because it's another thing to support, unless, of course, you have a use case to make it highly available. Then this sounds contradictory to my next point, which is add availability. But you're going to add availability where it matters. And that's on your certificate revocation list where those get published. So hopefully we all have some sort of availability plans, multiple sites or something along those lines. So put your certificate revocation lists in different sites and use load balancing or DNS round robin type techniques to get to those locations so that there's always a revocation list available for your clients to consume. This next one's a little bit weird. Use Microsoft Key Storage Provider. Essentially what this means is if you're using applications that still accept SHA-1 signatures, those applications suck, and you should make them go away. Microsoft Key Storage Provider gives you the ability to start using SHA-2 and up for your signatures. That's important. Pretty much all the browsers out there right now are saying, no, sorry, we're not going to accept SHA-1 anymore. And so this is a thing that you should build. If you're building one now, just do it right out from the gate. If it's not set up on your CA, don't fear. You can convert it. It's not terrible. And then lastly, research and plan. Spend a lot of time on the researching and the planning. Everybody gets caught up on the algorithms and key links. These are important. They're probably the least important of all the things that you do. Algorithms are important only for us, in this sake of this conversation, from a compatibility perspective. If you have Linux hosts in your environment or if you have weird applications in your environment, you should consider that they're the consumer of those algorithms. For example, if you start pushing out elliptical curve algorithms, most of your clients aren't going to understand them. They're the new cool thing. Not going to do you any good if they can't read them. Key links are important because it helps you decide how long your certificate should be valid for. We'll go through resources at the end of the slide to tell you how you can do some quick, simple lookups to decide how long your key links should be. Sorry, I just realized I have a ton of text on these slides. But we'll go through this. So maintenance considerations. This is doing stuff that most people won't notice because you did stuff, right? And one of these things is documentation. It's a little dig at Agile right here because people that do Agile development are like, I don't have to document things, I just write code. And that's not a good move for admins, right? Document all the things. So as you're building it, as you're designing it, write down what your configuration should be, write down what you actually did, write down physical locations of your offline root CA, which, by the way, if you're let's go back to the VM thing. If you're not building an offline route, you don't have any business. If you can't afford a cheap laptop, you have no business building a CA. Just don't do that. But record and document your locations of your offline route, of your backups, of who has the encryption keys for where your backups are, because of course your backups are encrypted. Subordinate CAs, lots and lots of use cases for just documenting stuff. If you have a question as to whether or not it should be documented, then it should. Okay, next maintenance consideration. This is one of my faves right here. It's a super cool tool that no one knows about. This is one of the best things we could do for our certificate authorities is just get visibility into what they're doing. And this kind of makes an assumption first that you already have a certificate authority in your environment. If you don't have one and you're building it, this should be a part of your plan. An SMTP Exit module is a native component within Microsoft certificate authorities that allows, it's all registry based, we can configure it, puts lots of settings in, and basically all it does is send us alerts. Based on what the certificate authority is doing. Some things that you can watch for are regular certificate revocation list publishing. That's a good thing. For some people, that would be annoying because basically you're going to get an email every time it's published. But I don't have a way to get an alert if it didn't get published. So when the emails disappear, something's unhealthy and the clock is ticking before my clients break. So it's good to watch that email. Second, get SMTP notifications when you're, get regular certificate request denials. And remember a little bit ago when I was talking about don't use the default templates? We're going to go back to that user template for a second. The basic user template requires that you have an email address in order to submit automatically with auto-enrollment and get a certificate back. How many of you have service accounts in your environment, though? And how many of those service accounts have email addresses? Like, none of them. And if they do, why? I suppose there's probably a use case. Maybe. Anyway, so as your service account logs in and does an auto-enrollment through group policy, and it requests a certificate because that's what it's supposed to do, your certificate authority is going to say, no, you haven't submitted enough information. And then it gets logged in the database. And then the next time the service account authenticates, which is like all the time, it's going to request it again, over and over and over, exponentially times the number of accounts that you have and continue to create. If you don't have an SMTP Exit module, you're never going to see that. In the meantime, your database is bloating with tons and tons and tons of denials. And inevitably, it will corrupt your entire certificate authority database, and you'll be rebuilding or restoring. So this is a good thing to watch. You should not have regular certificate request denials. One here and there, no big deal, but they shouldn't be consistent. Now, I will tell you, if you go back and you turn on your SMTP Exit modules at work on your CAs, point it to an email address that you don't care about because you're probably going to get a lot of emails. You also want your SMTP Exit module to point towards pending certificate requests because, again, we didn't use default templates. So our web server templates, by default, do automatic enrollment. So if I, as an end user, want a web certificate, I can say that I'm cool guy forever at secdsm.org, and it will just issue. There's no identity validation. There's no checking to see if I put an IP address or broke RFC or anything like that. There's no checking. It just says, yep, here's your cert. Thanks for coming. Please come again. In this case, we're going to change the default template, and we're going to say, don't auto-issue, require CA manager approval so that we can validate that the fields that were put into that request are legit. And because we require approval, it's going to go into a pending queue, and it's going to email us. We no longer have to watch the CA to hope that a certificate request comes in. So it's a really nice heads up. There's lots of other things in the SMTP Exit module that will be super helpful for us to just maintain things and make sure things are humming along smoothly. Some other things you can do from a maintenance perspective is schedule stuff regularly. These are things that I do. They're a bit anal retentive. Lots of people with CAs would argue with me. This is all my opinion. Some things that I like to do, though, is on my offline route, I schedule a pretty consistent certificate revocation list publish. That's one of the things that people only like to do about every 20 to 30 years. I like to do it annually, which is overkill. I do it annually because it keeps me in practice. It gives me a scheduled time to go look at some other health components. It gives me a time to do a backup, to restore my backup, and I also do Windows updates on my offline route. I'm going to have a lot of people argue with me on that one too because they're like, why? It's an offline route. It doesn't need updates. It's never going to connect to the network. But it has the capability to connect to the network, and I'd at least like for it to be patched if somebody accidentally does plug it in. So I'm going to go ahead and patch it. I'm going to go ahead and do a backup. I'm going to do a certificate revocation list, publish. And then on some other random machine, I'm going to make sure my restore works, and I'm going to document my entire process as I'm restoring so that when the DR event happens, I don't care. I'm just going to do the things that I did that year. On the health check perspective, I'm going to use a utility called PKI View. This is built in. It's all native tools. You just log in, you find PKI View, and it shows you health metrics. It gives you little red icons when stuff is broken and yellow icons when it looks bad-ish. If everything's good, it says it's good. So it's really simple. It can take you about 5 minutes to take a look. When there's warnings, go do some Googling. You'll be the coolest guy ever. Some consumption considerations. This is what application developers should be concerned about and people that are managing applications that would consume a PKI. So this point here that says having a PKI without proper consumption is at best case, useless, and at worst dangerous. And I say it's at worst dangerous because if somebody gets a hold of my private keys, they assume my identity, and now they're flying under the radar, and their attack is actually that much stronger. I've really just provided a tool for an attacker to take advantage of. So we really need to make sure that all the applications we're developing, or all the in-house or purchased, or whatever applications exist in our environment are doing these things. First, they need to be checking for the purpose of the certificate. If a certificate says it should be doing client authentication, don't allow it to do server authentication. Pretty simple concept, right? We want to look for name mismatch behavior. I can't tell you how many VPN endpoints, for example, will take my username, I'll submit my username, and then it will present the certificate, but I present maybe, I don't know, Nick's certificate. And it doesn't look at the subject name to see that the subject name of the certificate doesn't match the user that was submitted. That's like presenting a false ID. It's dumb. I shouldn't own that certificate. Next, your application should be doing trust chain validation. So not really sure how to explain that really quick, except for the fact that your certificate was issued by an authority. If you don't trust that authority, you don't trust the certificate. Every single authority in the entire chain should be checked to make sure that the client trusts it. If you have questions about that, we're going to have a time for that, and I'll totally answer any questions later as well. Time health is a big deal too. Your certificates have a validity date and time stamped across them. If your host is, I don't know, backdated, and then you're using an expired cert, the certificate is still valid, right? So if my host is up to date and my application never checks the timestamp of the certificate, my certificate is still valid, even though it's expired. So it's important that as applications, we check all of these fields that exist in order to make sure it's a legit cert. We also want to do certificate revocation list checking, and I put in the word behavior here because you need to decide, should my application fail open or fail closed? And I'm going to pick on Internet Explorer here for a second. So the default behavior of Internet Explorer is that when it sees a certificate, it wants to go out and it checks the certificate revocation list that's associated with that certificate. However, if the browser is unable to contact that list, it fails open. It just says, you're probably good. And it lets you browse. If that's not how you want your environment to work, if that's not acceptable risk for you, go change your browsers. Go change your applications to make sure they do what they ought to be doing. Some quick takeaways that we can do. Go back to your work, take 5 minutes, look at PKI View. Just get quick visibility into what your CA is doing. How healthy is it? It'll tell you like within a few minutes if it's good or not. Enable an SMTP Exit module. This is super simple, super quick, and worth lots of value when you get the visibility into your environment. Then go configure your applications. Look at like simple things like browsers. Just start there and see how you want your browser to go and deal with things like certificate revocation lists. And otherwise, just spend lots of time digging into your environment, seeing what settings exist, and document. And you'll get a lot of value out of doing those things. Otherwise, I wanted to throw up some quick resources. I think this is going to be online, right? So obviously, links don't do you any good in a presentation, but these are all really great stuff. I want to go through just a few of them. The everything you should know bullet point there is, like most of the things here, really old documentation. But this is a document that was put together by Mark Cooper, who I'll talk about in a second. And it is, in my opinion, mandatory reading before you do a CA. It goes through how you should design things, some of the same subjects that I talked about tonight, why you should design them that way, how you should harden things, things that you would never consider otherwise. The SMTP Exit module is totally a valuable site to go through. It gives you a quick overview on what you should be doing with it. Key length guidance is a place you can go for quick reference. If you just don't want to do the math and decide what key links you should use, go there. It will tell you based off of, if you're a NIST shop, this is where you need to be. If you want your keys to exist for 100 years, this is how long your keys should exist. Simple, simple stuff. Mark Cooper is somebody I want to talk about really quick. He is one of the original guys that helped build out the Microsoft CA platform. He no longer works for Microsoft, but basically everything that gets published on certificate services for Microsoft, he has a hand in it. He's totally worth talking to. He's a super casual guy. You can find him on LinkedIn. You can find all of his documents out on the web. And effectively, if a document says it was authored by Mark Cooper, it's worth a read. It's worth a very hard read. With that, questions? Go ahead.
Purchase versus free.
I've never had enough money to purchase, so I build what I have. I don't know that I could answer that. I've all my experiences with Microsoft CAs, and so, yeah, sorry.
So I know technically you said you didn't want to talk about not Microsoft CAs, but what is your opinion about Let's Encrypt?
I don't have one. Honestly, that's another, like, I put Microsoft CA just from the perspective that I just haven't done my homework elsewhere. It's just kind of the world that I live in. It sounds like an opportunity for you to talk on it, though. Sorry. Thoughts? Anyone else? Yeah.
So we have actually that ugly ADCS website you're talking about. Where I'm wondering, how do you take steps to rip out that network?
It's if people are still using it, then you've got a bigger problem. And the bigger problem is that you have old version templates. And if you have old version templates, you probably have an older CA that's using an older cryptographic service provider, which means you're probably also issuing SHA-1 certs, right? So there's kind of a rabbit trail thing going on. It doesn't mean all those things are true, but it means you should do some digging. You should definitely do some digging. If people aren't using it, just go uninstall IIS and like fixed, unless, of course, that's where you're publishing your certificate revocation lists, because that's a good opportunity to break things. Yep, so. Okay, with that, I'm going to pass it on. Thanks, everybody.